Hey everyone, Taufik here. Now, if you have an SQL query that is taking a very long time to execute, just try to create a materialized view on that SQL query and see the magic. Now, having said that, it does not mean you start creating a materialized view on each and every SQL query that is taking time, because the way how materialized view actually works in SQL is slightly different from any other database object. Now in this video, I'm going to give you all the information that you need to know about Materialized View. We shall see how does it actually improve the performance and how does actually Materialized View work. I'm also going to tell you what is the difference between a view and a materialized view. And of course, I'm going to explain all of these concepts practically. That is, we are going to create a table. I'm going to insert millions of records into that table. And then we will try to write a query on that table. And then we will see how does materialized view actually improve the performance of that query. Now, before I can start, I would like to mention two things. Number one is that materialized view is a concept that is common across all the other RDBMS. So no matter which RDBMS you are using, everything that you will be learning about materialized view in this video should be applicable to all. But of course, I'm going to just be using one RDBMS. I'm going to be using PostgreSQL in order to explain the concept of materialized view in this video. The second thing is, similar to practically learning Materialized View in this video, if you also want to practically learn all the other SQL concepts right from the scratch, that is from the most basic SQL concepts until the intermediate SQL concepts, and then also the advanced SQL concepts, and you want to practically learn, that is not just learn the SQL concepts but also learning how to practically use these concepts when solving SQL queries, then definitely consider joining my SQL course. I'm going to be starting my SQL course from 3rd August 2022. It's going to be a live and interactive training session. There are going to be 20 sessions. Each session is going to be of 1.5 hours long. It's going to be conducted on Lighthall, and all the other details about my SQL course, the course content, and all the other details is mentioned in my website. I'll leave the link to my website in the description below. So if you are interested in learning SQL the right way, definitely consider looking at my website and also joining my course. Now, before I can create a materialized view and show you how does it actually improve the performance, let's first try to understand what exactly is a materialized view. A materialized view is a database object. It is created over an SQL query similar to a view. But when you create a materialized view, it does two things, or basically it stores two things. The first thing is it's going to store the SQL query that is used to create that materialized view. And the second thing is it's also going to store the data that is returned from that SQL query. And this second reason is why Materialized View improves the performance of your query. Okay, so what happens is every time you execute the Materialized View, it's not going to internally execute the query that is associated with the Materialized View, but it's only going to return the data that is already stored in the Materialized View. Okay, and this is the reason why the performance of a Materialized View is so damn good. Now let's try to better understand this by taking some examples. So I'm just going to create a table. So I'm just going to say create table, and maybe I'm just going to name it like random table. Okay, and I'm going to have, let's say, two columns in this. So ID, it's going to have an integer value, and then I'm going to have a value corresponding to each ID, and let's say this is a decimal value. Okay, so I'm just going to create this table, and now I want to insert some records into this table. So I want to insert millions of records into this table so that I can show you how Materialized View actually improves the performance. Okay, now in PostgreSQL, if we wanted to insert a series of numbers, then we can use an inbuilt function called as a generate series. So I'm just going to do that. So I'm just going to say insert into random tab. And here I'm just going to write a query which is going to insert this series of numbers. So my first column is an ID. So let's say I'm just going to hard code it to 1. Okay. And my second column, let's say I'm just going to generate or fetch the random values from this generate series function. Okay. So I'm just going to say generate series, and I want to insert let's say 10 million records. Okay, so 1 2 3 1 2 3. Okay, this should hopefully fetch me 10 million records. Now if you have never used generate series, for example, let's say if I just say 10, okay, it's going to fetch me 10 randomly generated series of numbers. Okay, as you can see here. Now what I want to do is I want to insert 10 million records. So 1 2 3 1 2 3. Okay, so I think, yeah, it's 10 million records. Now if I execute this, it should insert me 10 million records, but I also want to insert one more ID. Okay, so with ID 1, I'll have 10 million records, and then I want to insert, let's say ID 2. Let's say this one also should have 10 million records. Okay, now I'm just going to execute both this insert, and this one is going to take a few seconds. So I'm just going to skip that. Okay, so it is done. Now you can see that it has inserted 20 million records. Now just to confirm that, I'm just going to say count of 1 from random tab. Okay, and you can now see that this is having, as you can see, 20 million records. So this is a pretty big table now. So we have created a table and we have inserted 20 million records into this table. Now what I want to do is I want to do some simple calculations on this table. I just want to write a query doing some simple calculations. So what I'm just going to do is I'm just going to say select ID. I'll find the average of these values corresponding to each ID. Okay, so I'm just going to say average of value, and I'm also going to count how many records are present corresponding to each ID. So I'm just going to say count of 1. You can use count of 1 or count of star, both are the same. And here I'm just going to say group by, let's say, ID. Okay, and now if I just execute this, it should fetch me 2 records because I'm doing a group by ID and there are only 2 IDs. But you can see it took 3 seconds, 218 milliseconds. Okay, so this query here took over 3 seconds to execute. Now this is just some random table that I created just for this demo, but when you're working on real projects, you might have some complex SQL queries which might take a few seconds to execute or a few minutes to execute. In that case, having a materialized view will really help. Okay, so I'm just going to go with this example. So if I execute this table, as you can see, it takes 3 seconds to execute, right? But let's say if I create a materialized view on this query, then you can see how fast the execution will happen. So in order to create a materialized view on this query, what I'm going to do is I'm just going to say create materialize view. Okay, it should be materialized view, and I'm going to give a name for this, like let's say MV, just a prefix MV underscore just stands for materialized view, and I'm just going to give the same table name. Okay, so MV underscore random tab, and the syntax is basically the same. I just need to say create materialized view, give a name for my materialized view, and then the as clause, and then the SQL query here. Okay, so the syntax is exactly similar to what we do in when creating a view. Okay, now I'm going to create this materialized view, and it's going to take maybe a few seconds. It took 3 seconds because it created the materialized view. As I told you, it's doing 2 things. It's going to store this query itself, and also it's going to store the result from this query. Okay, now in order to execute this materialized view, I can just write it like select star from the materialized view name, and if I execute it, you can see it's fetching the 2 records, and it just took 63 milliseconds. Okay, this is the difference. Now when I execute this materialized view, it's taking just around 60 milliseconds. But if I had to execute this entire query where we are fetching the data from the base table, you can see it's taking more time, and it's actually taking over 3 seconds. So over 3 seconds and 160 milliseconds. Okay, now this is a big difference. But let's say if you had a complex query which was taking maybe a few different seconds or a few minutes, then if you create a materialized view, you will see big improvement in the performance. Okay, now how did this actually happen? So you understood that if I just create a materialized view on this query, and then instead of executing this query, if I just execute from the materialized view, I will get the same data, but the performance is so much better. But how did actually SQL do that? The reason why SQL was able to improve the performance using materialized view is because when I created the materialized view, SQL had generated the data from this query, and this data was stored in the materialized view. So every time I executed this materialized view, it did not go back and execute the query again, but what it did was it just went to this materialized view, it saw the data that was stored for this materialized view, and it just returned that data. Okay, so it just went to the memory, it fetched the data that was already stored corresponding to this materialized view, and that data was just returned, and that is why it's faster. It's not going back to the database and executing this query. Okay, and that is why the performance is so much better. Now, of course, there is a catch, and the catch is that this data will not get automatically updated. Meaning, let's say if I change the data in this base table, that is in my random tab table, then Materialized View is not going to have that data updated automatically. We have to manually do that using a refresh. Okay. Now, what I mean by that is, for example, now we know that in our random tab table, I have two IDs, 1 and 2. Now I'm just going to delete one of these IDs. So let's say I'm just going to say delete from random tab, and I'm just going to say where ID equal to 1. Okay. This is having 10 million records. So I'm going to delete 10 million records from this table. Okay, so once I delete 10 million records from the base table, I'm going to query the base table again and see the data, and then we will see if this update has automatically come to Materialized View or not. Okay, so the deletion is successful. Now if I run my base query, that is from my base table, where I'm doing a group by from the random tab, you can see it's only fetching me one record and it's only having the ID 2. But if I do a query from my Materialized View, you can see it's still having the old data. Okay, why this happened was when the Materialized View was created, it had stored the data that it found when the creation happened, right? And even though after that, that table data got changed, Materialized View is not going to automatically update it. Okay, so if we want to update the data in the Materialized View, we will need to manually do a refresh. Okay, so for example, if I have to do a refresh of the Materialized View, I will need to run the command like refresh Materialized View and the Materialized View name, so mv underscore random tab. Okay, now if I run this refresh command, what it's going to internally do is, internally SQL went and executed the query, and whatever the data was returned from this query at this moment, it got stored into the Materialized View. Okay, so this is basically what a refresh happened. Okay, it's basically telling it's refreshing the data in the Materialized View, and now if I go and execute the Materialized View, it's going to get the latest data. Okay, now you can see I'm only having the ID 1. Now this is exactly the same as we have in our base table. So basically this is what a Materialized View is. We create Materialized View on a query, and when we create the Materialized View, it gets the data from that query and it is stored corresponding to that Materialized View. And even though there was a change in the base table, whether there is data getting updated, deleted, inserted or whatever, right, Materialized View is not going to automatically get these changes. Okay, in order for Materialized View to reflect these new changes, we will need to manually do a refresh on this Materialized View. Now some of you might ask, then what is the use of Materialized View? Because Materialized View is not going to have the latest data, right? And this is the reason in the beginning of the video I told you that do not create a Materialized View for each and every query that is taking time, because many times we might be executing a query and we expect the latest data to be showcased from that query, but several times when we are working on real-time projects or when we are building some product, we would not really bother about the latest data in the base table, or we would know that the data in the base table does not get updated or modified frequently, and in that case creating a Materialized View would be a much better approach on any query. Now from my personal experience, one of the projects where I actually created several Materialized View was when we were basically building some reports for one of the projects, and this report was something like the report table or the base table that we were using would get updated only once in a while. That is, I think it was monthly table, the data would get updated monthly, but then this report table itself would be used by multiple business users and stakeholders and clients and vendors, etc., and they would execute the data in the report several times in a day. Okay, in this case, if we had not created a Materialized View, then what would happen is every time any user or any vendor executed that report, it would internally basically execute the query, and several times these reports would have very complex queries which would take a few seconds to several minutes to execute, and it would be very bad for the performance, right? But instead of that, what we did was we created a Materialized View and we made sure that we refreshed the Materialized View every end of the day, because we knew that the base table would not get updated very frequently, and even if we just updated the data in a Materialized View once in a day, that would be still good enough, and the users and the vendors would just execute from the Materialized View, which would basically return the data very fast. Now I also want to talk about what is the difference between a Materialized View and a View. I already told you that Materialized View is basically storing two things, the SQL query and the data, but a View doesn't store the data. So for example, what I'm going to do is I'm just going to copy this same syntax, and down here I'm going to paste it here, and here instead of materialized view, I'm just going to create a view. The syntax is the same. I'm just going to give a new name, so I'm just going to prefix it with let's say VW. Okay, just stands for view, and I'm just going to execute it. Okay, now you can see that we have created the view, and now if I query the data from this view, so let's say I'm just going to query it here. Okay, so select star from my view, and if I run this, you can see it's still taking some time, and it took over 1 second to execute, whereas if I execute my materialized view, it's hardly taking few milliseconds. Okay, the reason for that is when I created a view, it just stored the query that was used to create this view. So every time I execute a view, it's actually internally going and executing this query. So when I'm executing a view, it's basically the same as executing this entire query itself. Okay, and that is why view basically does not improve any performance, but materialized view will improve the performance because it's not going to execute the query. It's going to return the data that is already stored. Okay, so the difference between a view and a materialized view is view will only store the select statement when it is created. Materialized view will store both the select statement as well as the data returned from that select statement. Okay, that's the first difference. The second difference is materialized view, every time you execute, it's only going to return the data that is already stored corresponding to that materialized view, whereas every time you execute a view, it's going to re-execute the query that is associated with the view every single time. Okay, so this is basically the two major difference between view and a materialized view. I hope this is clear. And I think that's all I wanted to explain about materialized view. Now, since we are using PostgreSQL, the concept of materialized view is made pretty simple. But let's say if you're using Oracle, then in materialized view, we could do a lot more things because there are several different types of refresh and there are few other things as well. Now, if you want me to make a separate video covering materialized view in Oracle, then leave a comment below. I'll try to cover them if you are interested. Okay, I hope this video was helpful and see you soon in the next one. Bye.